In this video, I'll be giving examples on the differentiation of trigonometric functions. So here are the formulas for the derivatives of such functions. For the derivative of sine of u, for any function u, it's equal to cosine u times the derivative of u, where u is the angle. For the derivative of cosine of function, cosine of u is equal to negative sine of u times du. The derivative of tangent of u is equal to secant squared of u times du. For the derivative of secant of u, it's secant u times tangent u times du. The derivative of cosecant of u is equal to negative cosecant u times cotangent of u times du. And lastly, the derivative of cotangent of u is equal to negative cosecant squared of u times du. Okay, let me also recall some trigonometric identities that we can use to simplify trigonometric functions. We have the three trigonometric identities derived from the Pythagorean theorem. I'll just be using theta for the angle, sine squared theta plus cosine squared theta. Of course, we can use any variable to represent the angle. And then we have 1 plus tangent squared theta is equal to secant squared theta. And then 1 plus cotangent squared theta, I hope you remember this, is equal to cosecant squared theta. So these are the three Pythagorean identities that you have encountered already, I think. We also have the quotient identities. Tangent theta is equal to sine theta over cosine theta. And just because cotangent is the reciprocal of tangent, so cotangent theta is equal to cosine theta over sine theta. We also have the reciprocal identities. So the reciprocal of sine function is cosecant. And so we also have cosecant theta is equal to 1 over sine theta. And then cosine theta is equal to 1 over secant theta. And it follows that secant theta is equal to 1 over cosine theta. And then tangent theta, as I mentioned a while ago, is the reciprocal of cotangent theta. So it's 1 over cotangent theta, and also cotangent theta is equal to 1 over tangent theta. We also have some double angle identities. Let me just name this. This is the Pythagorean identities. These are, the Pythagorean identities. Pythagorean identities. These are the reciprocal identities. And these are the quotient identities. And then we have double angle identities are here. Okay. So sine of 2 theta is equal to 2 sine theta cosine theta. And cosine 2 theta is equal to cosine squared theta minus sine squared theta. And it's also equal to 2 cosine squared theta minus 1. And also equal to 1 minus 2 sine squared theta. Based on the Pythagorean identities. So there are many more trigonometric identities, but these are the most commonly used identities. So we can use this to simplify our final answers or the function given. So familiarize yourselves with the derivatives of trigonometric functions and these identities. So in the next examples, we have to find the first derivatives of the following functions. Example number 1. So a very simple trigonometric function, y equals cosecant of 7x. The angle here is 7x. So you just have to write the function in the form y equals cosecant of u. So in this case, let the angle be equal to u. Okay, so for the derivative of cosecant function, cosecant u is equal to negative cosecant u cotangent u times du. So y prime is equal to negative cosecant u cotangent u times du, the derivative of 7x. So y prime is equal to, the derivative of 7x is 7, so it's a negative 7 cosecant 7x cotangent of 7x. Okay, this is the derivative of the function. So if w is equal to tangent to theta, you have to write the function in the form tangent of u. So in this case, let u be equal to the angle, and we'll get the derivative of w with respect to theta, okay, because the independent variable is theta, is equal to, our formula is secant squared. I hope you have your copies of the formulas. Secant squared u times du. Remember, we are differentiating with respect to theta. And the derivative of 2 theta with respect to theta is 2. So that's 2 secant squared 2 theta. This is the derivative of w with respect to theta. The function is in number 3 is a power of sine 3t. So we'll be using, our main formula here is the general power rule. This is actually, when you rewrite this, you can rewrite the function as z equals sine 3t raised to 2. So it's a power of sine 3t. So in this case, in the general power rule, let u be equal to the base. This is u. So the derivative of z with respect to t, the independent variable here is t. Using power rule, in the general power rule, what we do is bring down the exponent, copy the base, subtract 1 from the exponent, so the exponent 2 becomes 1, times the derivative of the base. The base is sine of 3t. Okay, so the base is sine of 3t, so it's in the form sine of u. So it's 2 sine of 3t times the derivative of sine of 3t. The derivative of sine of u according to the formula is cosine of u, where u is 3t, times the derivative of u, where u is the angle 3t. Don't forget that. When differentiating trigonometric functions, you always have to differentiate the angle also. So it's 2 sine 3t times cosine 3t times 3. Okay, remember this. In the double angle identity, sine 2 theta is equal to 2 sine theta cosine theta. So if this angle is theta, you double it when you simplify, it becomes sine 2 theta, right? So that encircled portion is equal to sine of 2 times the angle, where the angle is 3t. So going back, it's the encircled portion is actually sine of 2 times 3t is 60 times 3, or that is 3 sine 60. This is the derivative of z with respect to t in simplified form. Cosine cubed of 2x. So this is a power of cosine. We can write this as cosine of 2x raised to 3. So when we differentiate, we'll use the general power rule and let u be equal to the base. U be equal to the base cosine 2x. So y prime, using the general power rule, is 3 times cosine 2x. Subtracting 1 from the exponent, we'll get 2 times the derivative of the base. The base is cosine 2x. And the base is in the form cosine u. The derivative of cosine u is negative sine u times du. So it's 3 cosine 2x squared. You can write this in that way. Times the derivative of cosine 2x, which is negative sine of 2x, times the derivative of the angle 2x. Okay? So it's y prime, you write the next line here, equals 3 cosine squared 2x times negative sine 2x. Derivative of 2x with respect to x is 2. So just multiply all the constants and we'll get y prime equals negative 6. Negative 1 times 2 times 3 is negative 6 cosine squared 2x sine 2x. Okay, this is the derivative of the function. Number 5 is a sine function where u is another trigonometric expression, cosine x. This is u. So if you write the function in the form sine u, its derivative will be in the form cosine u du. So y prime is equal to the derivative of sine u is cosine of u, where u is cosine of x, times du, where u is cosine of x. So it's cosine of x times the derivative of cosine of x, which is negative sine of x, times the derivative of the angle x with respect to x. That's just equal to 1, so no need to write it anymore. So the answer is sine x cosine. I just rearranged the expression. So this is y prime. Now, number 6, the function f is a product of two trigonometric expressions. So we need to use the product rule here to differentiate, where u is equal to sine to the fourth x and v is equal to cosine to the fourth x. So we need to use the product rule. So u, let me just rewrite, u is equal to sine x raised to 4. So to differentiate u, we'll use the generalized power rule, and then v is equal to cosine x raised to 4. So from there, you get du using power rule, 4 times sine x cubed times derivative of sine x, the derivative of the base. So du is equal to 4 sine cubed x. The derivative of sine x is cosine x. That's it. Well, dv, using the same rule, general power rule, is 4 cosine x cubed times derivative of the base, this time derivative of cosine x. So dv is equal to 4 cosine cube x. The derivative of cosine x is negative sine x. So I'll just write negative here, negative 1 sine x. So that's dv. So going back to f prime of x using product rule is u times dv. So u is sine to the fourth x times dv, negative 4 cosine cubed x sine x, plus v cosine to the fourth x times du. Du is 4 sine cubed x cosine x. Just rewriting, we have a negative 4 cosine cubed x sine to the fifth x. Multiplying sine x and sine to the fourth x, we get sine to the fifth x. Okay, plus 4. That's a cosine to the fifth x sine cubed x. Okay, we can factor out. Let's see if we can still simplify this. We can factor out negative 4 common expressions between the two terms. Let me just write this on top. So f prime of x, negative 4 factor out. Common term or common expression between the two terms, negative 4, not just negative 4, we have cosine cube x. You can factor out cosine cube x also, and then sine cube x. So upon factoring this expression from the two terms, we'll have in the first term, so negative 4 is factored out, cosine cube is factored out from here, sine cube is factored out, what's left is sine squared x. So from the second term, factoring negative 4, we'll have minus here. minus, and then factoring cosine cubed, we'll have cosine squared left. And sine cubed x is also factored out. So that's it. So let me just recall the double angle identity. That cosine 2 theta is equal to cosine squared theta minus sine squared theta. Now, that part is negative cosine 2 theta because it's equal to negative cosine theta, cosine squared theta minus or plus sine squared theta. Okay, so that's negative cosine 2 theta. The expression inside the grouping symbol. So f prime of x is equal to negative 4 cosine cubed x sine cubed x times negative cosine 2. No, we're not using theta there. We're using x. So 2x. So that's negative times a negative 4. It's just a positive 4. Cosine cubed x sine cubed x cosine 2x. This is the derivative of f of x. Now, example number 7, we have a function which is a quotient of cosine 2 theta and 1 minus sine 2 theta. So using the quotient rule, let u be equal to the numerator and let v be equal to the denominator. So if u is cosine 2 theta, we differentiate with respect to theta to get du. And du is negative sine 2 theta times the derivative of 2 theta with respect to theta. So it's negative sine 2 theta times the derivative of 2 theta, which is 2. This is du. So dv is the derivative of 1 minus sine 2 theta. So it's 0. The derivative of 1 is 0 minus the derivative of sine 2 theta. That's cosine 2 theta times the derivative of the angle, 2 theta. So dv is equal to negative cosine 2 theta. The derivative of 2 theta with respect to theta is 2. Okay, so y prime, or not y prime, it's the derivative of y with respect to theta, dy over d theta, using the quotient rule, is equal to v, 1 minus sine 2 theta, times du, where du is negative 2 sine 2 theta, minus u, cosine 2 theta, times dv, negative 2 cosine 2 theta, all over the denominator 1 minus sine 2 theta squared. Removing the grouping symbols in the numerator, we distribute. Okay, and multiply these two. So we'll have negative 2 sine 2 theta plus 2 sine 2 theta squared. And then the last term would be plus cosine 2 theta squared. Now we have 2 here. Yep. Okay, so all over 1 minus sine 2 theta, quantity squared. Okay, in these two terms, from these two terms, if we try to factor out 2, we'll have negative 2 sine 2 theta plus 2 times the quantity sine squared 2 theta plus cosine squared 2 theta all over 1 minus sine 2 theta squared. And this part, according to a Pythagorean identity, is equal to 1. The first Pythagorean identity that I gave you. So it's just negative 2 sine 2 theta plus 2, because the encircled portion is equal to 1. So plus 2 only, all over 1 minus sine 2 theta, quantity squared. And again, from the two terms above, in the numerator, we can factor out dy over d theta. We can factor out 2. From factoring, okay, we'll have minus sine 2 theta plus 1 over 1 minus sine 2 theta squared. Now, if you'll notice this, and these are the same. Okay, so we can divide. So if I rewrite, that's 2 times 1 minus sine 2 theta over 1 minus sine 2 theta quantity squared. So we can divide them because they have the same basis, and then just subtract the exponents. So this will be cancelled out, and the exponent in the denominator becomes 1. So the simplified form of the final answer is dy over d theta equals 2 over 1 minus sine 2 theta. This is the derivative of y with respect to theta.